My dear friends, this is a tutorial for studies regarding civil service entrance exam for biology, physics, chemistry at class 10 level. Now we are going to do some problems in physics. Here we are going to solve some problems from the chapter force, and then we will do some calorimetric problems. So let's begin. The first problem is a force of 300 Newton is used by a horse to move the system of horse and cart with an initial velocity of 18 km per hour. What will be the power developed by the horse in watt and in horsepower? We know that force given here is 300 Newton. Initial velocity u is equal to 18 km per hour. We have to convert it in meter per second because everything is given in SI unit. So 18 km per hour is equal to 5 meter per second, as you can see the calculations. Therefore the power is force into velocity. There is 300 Newton into 5 meter per second, that is 1500 watt. Now for conversion of watt into horsepower, we know that 1 horsepower is equal to 746 watt. Then this much watt is equal to how much horsepower? So 1500 divided by 746, that is equal to 2.01 horsepower. So this is done. Problem number 2 is power of an agent is known to be 1 watt if 1 joule of work is done in 1 second. If an average horse has the power to lift 550 pounds through 1 foot in 1 second, what will be the power in watt? 1 foot is equal to 30.48 centimeter and 1 pound is equal to 0.454 kg. Now we are converting this mass into kg and 1 foot into meter. That's 30.48 centimeter, that means 0.3048 meter. So here you can see mgh is equal to this thing. In SI unit it is given like this. So we are getting it at 746 watt, which we have proved in this way. 1 horsepower is equal to 746 watt. That is this formula. Using this formula we can show that 1 horsepower is equal to 746 watt. So question number 3. A man weighing 50 kg goes upstairs, reaches a height of 8 meter in 5 seconds. What will be? Number 1, the force of gravity acting on the man. If we take acceleration due to gravity g is equal to 10 meters per second square, we have to find the work done against gravity and we have to find the power developed. So coming to number 1, the force of gravity acting is equal to m into g, that is 50 into 10, that is 500 Newton. Work done against gravity is equal to mgh, 50 into 10 into 8, that is 4000 joule, and power developed is equal to work by time, 4000 joule by 5 seconds, that is equal to 800 watt. Number 4, how fast should a man weighing 60 kg run in order to make the kinetic energy to be 750 joule? We know the formula of kinetic energy is equal to half mv square. Here we have to find out v. V is equal to root over 2k, means 2 into kinetic energy by mass. So we are getting here, using this formula, we are getting this as 5 meter per second. Number 5 is almost similar to this sum. A body weighing 40 Newton moves with kinetic energy 500 joule. Calculate the velocity. Again take the G is equal to 10 meter per second square. So here we have velocity is equal to 2k by m this is 40 Newton. 2 into k is equal to 500 joule and mass is equal to here we have 400 Newton. If it is 400 Newton, then the mass is 40 kg since G is equal to 10 meter per second square. So here we are getting 2 into 500 by 40 is equal to 25, root over 25 is equal to 5 meter per second. So these are the sums on force. Now coming to the sums on calorimetry, how can the heat required to raise the temperature of water by a certain amount be compared to heat required to raise the same mass of iron by the same amount? It's given that specific heat capacity of water is equal to 4186 joule per kg per degree Celsius and specific heat capacity of iron is equal to 452 joule per kg per degree Celsius. Given that mass of water is equal to mass of iron, that is m. We also know that temperature of both are same, so let's take it as theta 1. Now heat required to raise the temperature of water is equal to m into C1 into theta 1. M is same for both, so m into heat of water is equal to m into 4186 into theta 1, and similarly heat required to raise the temperature of iron is m into 452 into theta 1. Now the ratio is, since we are into comparison, we have to take the ratio. So the ratio is 9.2610, approximately 9.26. Hence water requires 9.26 times more heat energy than that of iron. Number 7. If liquid P having specific heat capacity of 0.88 joule per gram per degree Celsius at 40 degrees Celsius is to be mixed with liquid B having 100 gram mass, specific heat is 2.2 joule per gram per degree Celsius at 20 degrees Celsius, so that the final temperature becomes 32 degrees Celsius. What will be the required mass of liquid P? So here let the mass of liquid P required be x gram. Let's take it as x gram. We know that this is a hot body, so there is a fall in temperature for this liquid. There is 40 minus 32 degrees Celsius. The final temperature is 32. So 40 was its initial. So here 40 minus 32 is equal to 8 degree, and rise in temperature for liquid B is equal to 32 minus 20. That is 12 degrees Celsius. Heat lost by liquid P is equal to x into 0.88 into 8 joule. Heat gained by liquid B is equal to 100 into 2.2 into 12 joule. 100 means here the mass is 100 gram. So using principle of calorimetry. What is the principle of calorimetry? Heat lost by a hot body is equal to heat gained by a cold body. So we equate them and we get x is equal to 375 gram in this process. You can just see. So please like and share this video to as many children as possible, as many civil service aspirants as possible. So please subscribe my channel. Thank you very much.